Okay, let's start with video number 2. Okay, so before I proceed, let me be corrected. Ano? Start corrected dito sa discuss ko kanina regarding this strain value na 0.02. Okay, yung strain in concrete, which is actually 0.003. I mean yung 0.003, hindi yung 0.002. So, ano yan, yung sinabi ko kanina. So, actually yung 0.002 is summary here, dito. And yung value na yan yung makikita natin doon sa strain diagram as the value of ECU, actually, the ultimate concrete strain ECU equal to 0.003. Although, tama naman dito sa diagram, makikita natin na yung concrete strain, compressive strength curve, pagdating sa 0.002, nagbari talaga siya, no? Bumabase. So, significantly makikita dito sa banda ito sa 5,000. Medyo dito siya. Pero halos ito, 2,000, 3,000, 4,000. Especially itong dalawa na ito. Talagang nasa siya, sa 0.00 strain. Yung change of behavior niya. But we use now yung design yung 0.003. Okay. So, sana stand corrected na. By the way, kasi yung kanina sinasabi ko, yung strain na 0.003. Yung, strain na 0.002. So, still yan, 0.002. So, makikita niya na pag third video, I will discuss yung 0.002. Okay. So, ando na tayo sa behavior of reinforced concrete. Actually, we'll be dealing with behavior of concrete and due to loads. Okay. Okay. So, we have 3 stages here. 3 stages. Number 1 is yung uncracked concrete stage, decracked stage, elastic behavior, and we have the ultimate strength stage or the beam failure criterion. Okay, so may mga topics sa strength ka na makikita nyo sa YouTube ko sa review yung crack and uncrack. Crack and uncrack section ng concrete. Actually, gamitin natin ito sa deflection. Okay. So, we have here the modulus of rupture and we have the cracking moment. So, kumbaga, kung kunin natin yung FR, ang formula natin, di ba, yung MC over I. So, we have MCR, then I, pero yung I is I gross. And we have the C in the tension part. Tension part ng concrete. We are dealing here with concrete We are dealing with concrete, hindi yung steel. Okay. Ngayon, meron dyan I gross. I gross ang ginagamit natin kasi nga uncrack Okay, uncrack. Okay, so we have here the FC prime, FR, MCR, I gross, and distance. Then makikita nyo dito, we have the cross-section, strain diagram, and distress diagram. Okay. So, dito sa diagram dito, medyo may error. Ito dapat, dito sa line na ito, dito dapat. Okay, dito din. So, it is on the centroid ng steel. Okay, so, dapat hanggang dito lang siya. wala na dapat itong portion na ito. In a way, kasi yung nag-drawing. So, this is strain diagram and this is stress diagram. Kung makikita nyo dyan, it is composite kasi may concrete at saka may steel. Pero since uncrack stage pa siya, ang tinutukoy natin dyan yung plain concrete lang. Ha? When the concrete is uncracked, it behaves sa plain concrete lang, homogeneous. Okay, so at this level, we have the strain and tension, the steel, and we have the compression. Then sa stress diagram naman, we have here Fs over N, and we have Fc. Okay. Now, itong point na ito dito. Yan. Ganyan. Pag dinerecho natin dito yan, actually yan yung location ng neutral axis. So actually sa ano yan, C. Kaya lang dito sa uncrack na tatawag as K times D. KD. So the factor of the effective depth D. Ito yung effective depth na K. By the way, by definition, ano yung effective D? Marami kasi yung nagkakamali dyan eh. Okay, this D is actually the distance of the tension steel area, centroid ng tension steel from the extreme concrete portion. Extreme concrete doon sa pinakataas. So, andito yung AES natin. So, centroid siya kasi sometimes meron tayo ng reinforced concrete wherein yung steel natin is 2 layer. Halimbawa, 3 dito. Tapos dito 2. Kasi, kumbaga 5 ang kailangan natin, then congested siya kapag nilagay natin sa 1 layer lang. So, lalabas. Ito, hindi ito yung D. Hindi yan yung D. Ang D, from the centroid nung 5 hanggang dito sa extreme concrete fiber and compression. Yun yung D. Okay. Usually ito, designated na lang natin as DT. And tension. So, doon na lang natin take up kung ano yung D at saka DT. Okay. Now, okay. Dito sa diagram na ito, sabi dito tension and compression. The designation for this actual stress and steel and tension is Fs. Okay, Fs. In compression, meron siyang prime. So we have Fs prime. And usually, this is compared with the value of Fy. Okay? Fy. Kapag ka na-exceed niya yung Fy, so yung Fs, kapag ka na-exceed yung Fy, ibig sabihin greater than or equal to Fy, ang gagamitin lang natin na Fs, equal to Fy lang. Kasi nga, tingnan nyo doon sa plastic material table, diba? Pinamaximum natin doon is Fy lang. Ngayon, if Fs prime is less than Fy, siyempre, ang gagamitin natin yung actual value ng Fs prime, which is less than Fy. Kumbaga, elastoplastic di ba? Ganyan yung natin, strain diagram. So, ito, Fy yan eh. Fy. Okay. Then, andito yung yield point. So, yung value ng strain dito, yung strain at yielding. Ngayon, actually, pag diniretso natin doon, makukuha mo yung Fs at this level. Ito yung strain niya, actual strain. Yes. Ngayon, since idealized as elastoplastic material yung reinforcement natin, hindi tayo pwede gumamit ng sobra sa Fy. That's why our limit for the value of Fs and Fs prime is Fy. Na? Okay. So, gano'n yan. So, sabi dito, Fs greater than Fy. When F is greater than Fy, we have to use Fs equal to Fy, and our actual strain will be equal to strain Y. And if it is greater than Fs prime equal to Fy, then for the value of Fs prime and Fs, okay, yung actual Fs natin will be strain S. That's the modulus of elasticity. Actually, this is Hawks to eh. Ito, same din. Kasi nga, dito siya sa portion na ito dito. Elastic behavior ba, ano? Elastic behavior. Kaya we can use Hawks law dito. Di ba sabi ko, ang Hawks law is only valid on this region. Dito hindi na. That's why Fy na lang gamitin natin dito. Okay. Now, before we proceed with the example, then ganito kasi yung, ano na, behavior actually ng, let's have example yung beam. Then, lagyan natin ang load. So, if this is your beam, and meron siyang support dito, hinge support, then roller. Then, lagyan natin ang load. For example, concentrated load at the midspan. Okay. Then, alam niyo naman yung shear diagram niyan. So, ang i-draw ko na lang dito yung moment diagram na. So, yung moment diagram na, ganyan na. Kaya yung moment diagram. Then, yung value nito, yung maximum, PL over 4. Tama. Moment maximum is equal to PL over 4. So, kailangan nyo dito yung mga formula. Memorize nyo na lang. So, sa statics, sa deformable bodies, sa theory of structural theory. Kaya dapat marami na kayong nalalaman dyan. Ngayon, dito tayo critical sa portion sa midspan. Kapag ginawa natin yung section dyan, then yung load natin, in-increase natin. So, increase natin yung load. Okay. So, mangyayari ng concrete natin, kasi kumbaga, sa assume singly reinforced yan. So, meron tayong tinatawag na modulus of rupture at R. Then, from there, makukuha natin yung cracking moment MCR. Okay. So, when F4 is not reached, ibig sabihin, uncrack siya. Uncrack. So, kapag uncrack yung concrete natin, yung beam, for example, yung beam section, kumbaga parang in the computation of the moment of inertia, hindi mo natin gagamitin yung steel, hindi mo na siya kasama. So, plain concrete lang siya. Homogeneous concrete. Kaya ang ginagamit natin yung IG, I gross. Ayan. So, kung rectangular yan, ang I natin will be BH cube over 12. BH cube over 12. Centroidal. Ngayon, kapag in-increase natin yung load, na ma-reach yung FR, magkakaroon na siya ng crack. And na-reach na yung MCR, mag-crack na dito. Mag-crack dito. Actually, yung cracking dito muna yung mag-umpisa. Then habang dinadagdagan natin yung load, yung crack mag-extend pataas hanggang makarating doon sa neutral axis, wherein ang ginagawa natin dyan, neglect na natin yung capacity ng concrete intention. Kaya mayayari yung section mo, ganito na. Ganito na yung section mo. Andito yung neutral axis. Then, andito yung steel. Yan, ganyan. Okay. So, gawin na lang muna natin itong X. And meron tayong B dito. So, the moment of inertia with respect to the neutral axis for this concrete section will be BH cube over 3 with respect to base. With respect to base. Then, siyempre, kung nga dyan, concrete ito, then this is steel. Anong ginagawa natin dyan? Sa strength of materials, di ba? We have to convert that into a homogeneous material. So, gagawin natin dito, Yung steel, gagawin natin concrete. Yan. And ngayon, kapag ka okay, luluto ko kami isan. Okay. So, ito na, magiging ganyan yung area niya. Then, ang gagawin nating area dyan will be NAS. Okay, by the way, ano yung N? Yung N is the modular ratio N, which is equal to ES over E sub C. So, sabi ko sa strength, kapag composite material siya, express in concrete siya, kailangan yung modular ratio mo will be in terms of ES and AC. Then kung ano yung material na transformation niya. So yung steel, ginawa natin is concrete. So nasa baba, sa divisor yung EC. And this ratio is ranging around 9, something 8 to 9. Depende na. Kasi yung ES is 200,000. Then yung EC is 4,700 is cut of FC prime. Okay, this cut of FC prime. Okay? So, kung makikita nyo, transform section yan. And ang magiging computation ng moment of inertia yan, ito will be with respect to the base. Then ito, yung centroidal nito, ita-transfer natin dun. Kaya lang, since this is a wide rectangular section, yung centroidal yan magiging BT cube. Ano na yun? Thickness na BT cube over 12. Diba? Plus AD squared. AD squared. Ngayon, itong T, since maliit yan, tapos raised to 3 pa, so negligible yung value na to. Kaya makikita nyo mamaya sa example natin, wala nang BT cube over 12. Okay? So, ando ba ako sa behavior mo na? Then, kumbaga, sabi ko kanina, plain concrete pa siya, uncrack. Then, pag na-reach na yung MCR, magiging crack section na siya. Ang gagamitin na natin yung transform section. Okay. Now, ang ano natin dyan, ang strain diagram kapag uncrack. Ito pa, ganito ba? Ganito ba? Okay, ganyan. Ngayon, kapag in-increase pa natin yung load, ang mangyayari dyan, yung stress diagram mo dito, magiging parabolic na ito, magiging parabolic. Actually, pag ganyan. Kaya lang itong portion na ito dito, hindi natin consider kasi neglected na nga. Yung steel lang. Kaya ito magiging parabolic. Yan. Then mag-cross pa rin ito sa neutral axis. Okay. And that is now the ultimate strength criterion. I will just explain kung ano ito pagdating natin sa topic na yan. So, for our example, mag-erase muna tayo. Okay. Erase muna tayo. Okay. So, for our example, problem number 1, determine the cracking moment of the section shown if FC prime is equal to 28 and F. The modulus of rupture F4 is 0.70 discard of FC prime. Okay. So, madali lang kasi yung ano niya, ito yung section natin, 500 by 300. Then, meron tayong dalawang 25 mm. FC prime is 28. And FR will be equal to 3.7. A computation of MCR will be equal to 46.25. So, ano dito yung IG? So, kumbaga, useless yung steel. Concrete lang siya. Okay, and makukuha natin yung MCR. At the value of F ng concrete mo will be equal to FR. FR. Okay? So, madali lang yan. Then next, we have for T-beam. Ang gagawin natin dyan, ganito siya. Okay.
Ako po, mama.
Ay, sarap ng ice cream. Ice cream muna ako, ha?
Kasama yan dahil?
Para medyo tawa kayo. Sarap. Anyway. So ito, T-beam. So assuming na andito yung neutral axis. So gross. Okay, uncrack tayo, di ba? So first, you have to locate the location of the neutral axis. Solid Android. So alam niya yan. Statics lang naman yan. Then, di ba, andito yung tension. Kaya andito magka-crack. That is assuming na andito pa rin yung AES natin. So, meaning, positive moment ang acting. So, tension dito, compression sa taas. Yung CT galing from the neutral axis to the extreme tension portion ng concrete. Kaya, yun yung CT. Then, paano natin kukunin yung moment of inertia? Dapat alam nyo na yan, ha? Meron tayo ng dagdag bawas. Okay? So, madali. Ito na lang. Buuin nyo. Rectangle minus 2 rectangle. Okay? So, ito ngayon yung IG. And from there, na-solve mo yung IG. Then, you can now solve for MCR. And therefore, the cracking moment is 39.27. Okay? Walang issue dun, ha? Online tayo ngayon, kaya may video kong piniprepare, pero hindi, iba lang siya sa face-to-face, pero kaya niyan. So, tapos na tayo sa uncrack. So, kapag ka nag-crack, sabi ko, ibig sabihin, nag-crack siya when your applied moment is greater than MCR. Na-reach na yung FR, kaya nag-crack. So, kapag ka nag-crack siya, ang gagawin natin, effective na ngayon yung steel. So, gagawin natin is yung transform section, wherein the depth of the compression part ng concrete will be equal to actually to C, or that is C is equal to KD. C is equal to KD. Working stress design actually yan. Okay. So ngayon, sabi ko, papalitan mo ito ng AS. AS pa rin siya, pero multiply natin ng N para maging concrete siya. So again, paano mo kukunin yung moment of inertia dito sa neutral axis? Ito is rectangle with respect to base, BH cube over 3. Then ito naman plus centroidal, BT cube over 12 neglected plus NAS times the distance. If this is D, and that is KD, so this is, okay, this is D, and this is KD, so this is equal to D minus KD. And that is KD yan. Okay? So, makikita nyo dito sa solution dito, first, you have to solve for C. Okay? Sa strength of materials, paano ba solve yung C? Okay, just equate the statical moment of area dito. So dito, take ng moment dyan, considering this area, then yung centroid at sa gitna. So kaya we have B times C, that is that area. Then times the moment arm, this is C over 2. Will be equated to NAS times the distance D minus C. So from there, you can solve for C. Then, kapag ka mo na yung C, you can now compute for the moment of inertia. Okay. So, meron ka ng moment of inertia. That I actually is crack na yan. Pero hindi yan yung ICR. Kasi, yes, crack yan. ICR yan. Now, paano natin kinocompute yung stress anti-concrete steel? Okay? So, we use the flexural stress formula MC over I. Since yung natin, transform section is concrete, kapag concrete, walang N na kailangan. So, dito, actually, yung mangyayari, yung Fs over N yan will be equal to MCI Then yung N, lagay natin doon kaya magiging N, MCI. So we have 9, yung N natin, then we have M is 130, then yung C is equal to KD, 530 minus 203.4 and divided by I, CR. And you will have positive, of course positive yung sa steel kasi yung tension yan dyan, and then in the concrete in compression. Okay, so self-study na yan. Then next we have for double reinforced. Okay, so for double reinforced, meron tayo dito ng crack. This is crack section. So meron tayo dito ng NAS. Then dun sa taas, meron tayong 2N minus 1 AS prime. Kapag in compression yan, ang natin dyan, gagamitin natin is 2N. Ngayon, bakit merong 1 minus 1? Kasi kumbaga 2N, we have AS, 2N AS, then minus AS prime. Okay. AS prime din dito. That is kasi 'di ba, this is in compression, effective yung concrete section. Ngayon, kung ito yung steel, 'di ba meron siyang occupied volume or area. So kaya meron 1 doon kasi kumbaga we have to subtract AS prime. Kaya dito, bakit dito N lang, doon 2N, this is in compression. The explanation there is because of bond. Kaya double twice. Okay, pero may ano pa, mas may maganda pang explanation yan. Tingnan nyo sa books. Okay. Isa lang sa pwedeng itanong ko sa inyo sa problem sets or assignments. So, ito yan. Ito yung explanation ko dito. Then yung 2N is dito band. And yung AS prime will be the displaced concrete kaya meron tayo doon ng minus 1. Okay. Paano i-locate yung neutral axis? Okay, balik tayo doon. Ganito lang, madali lang. Sa concrete, BH cube over 3. Ito naman is NAS times this minus C over 2. Then ito naman, ibig sabihin, 2N minus 1 AS prime multiplied by 1 half of C. 1 half of C. Okay. Yun yung sa moment of inertia. Then how are we going to compute for the location X or C? Sabi ko kanina, yung statical moment of area, kunin mo dito. Moment ka dito for the concrete plus yung sa steel in compression equated to the steel in tension. Kaya makikita mo dito. So we have, this is for the concrete, this is for the steel in compression, and this is the steel in tension. Okay, so we'll get C equal to 187. Then the moment of inertia, again, for the concrete, BH cube over 3. For the NAS, 2N, this is 2N. This is for the AS prime. And this is for AS. By the way, yung AS prime is the area of steel in compression. Meron tayong prime. Then ito yung area ng concrete yung effective. Kasi nga, yung area and tension is already neglected. Then again, for the stresses, so we have for FC, walang problema, hindi kailangan ng N. For FS, N lang. Okay, FS prime, 2N. Okay, huwag kayo magkakamali, baka magawa nyo 2N minus 1 yan. Okay, mali yan. Huwag nyo gawing 2N minus 1. 2N lang dapat. Then you have this in compression. This is also in compression. This is in tension. Okay, so actually, saan natin gagamitin itong dalawa na ito, yung crack and uncrack? Okay, we will take up serviceability sa deflection. And actually, kasi mamaya sabihin ko na lang, meron tayong ano yan, yung WSD at saka yung USD. Okay, USD. So part ng WSD pa itong ano the uncrack and crack section. Okay. Ngayon, kapag in-increase mo pa yung load, ano na mangyayari? Okay. So, kanina, sabi ko ito, the stress diagram is triangular, passing through the centroid, magiging parabolic na yan. Then yung ano niya, although ang maximum, ang extreme fiber natin in compression nasa taas, Yung maximum andito sa banda rito. Dito sa banda rito. By studies, ano? By test. Sa strain diagram, walang problema. Kasi palaging ganito yan. Okay. Then, ito, dito, actually, beam failure concept na tayo. Diyan napapasok yung USD. Papasok yung USD. So, papasok yung USD. Then, makikita nyo, if you read books, maraming na-present na diagram nito. Merong parabolic, merong trapezoidal. Then, yung pinaka ginamit natin, yung rectangular. Yung rectangular was presented by Whitney. Kaya tinawag na Whitney rectangular stress distribution. Then, siyempre, if this is your neutral axis, kapag ginamit mo na yung rectangular, ito na lang yung magiging niya, area in compression effective. Then, meron yan dyan ng depth. Yan, yung depth of compression block A. A ang designation. Ito pa rin is C. C. So, statics lang naman actually ang solution dito. Ito yung resultant ng tension sa steel. Ito naman yung resultant ng compression ng concrete, CC. Okay, di ba? Couple ito couple. So, it will produce moment, and that is simply yung moment resistance. Then, if you take equilibrium equation, sabing na forces horizontal, CC or C will be equal to T. Okay. So, that is the ultimate strength concept. Okay. So, that ends our video number 2. Okay. So, huwag niyo kalimutan yung sa strain ng concrete, yung 0.002, 0.003 yan.